Before starting this next unit, which will deal with a lot of different trig identities and introduce a lot of new formulas related to our trig functions, we need to really understand what it means to verify versus what it means to solve something. So you have been solving equations since probably 5th, 6th grade, whenever you're introduced to the very beginning of algebra. And when I say solving equations, I'm talking about something like this. So when you solve this, you learn things like, oh, I need to get like terms together. I have to move across the equal sign, so I need to do the opposite and subtract 3x, or maybe you'd bring the 2x to the other side. And I know, oh, I need to, subtract the 5, right? Now I have negative x, because that cancels to 0, equals negative 12. Oh, divide by negative 1. Okay, we are allowed to do all of the steps we just did because we can assume the left hand side, does indeed equal the right hand side. So from now on, I'm going to call this just LHS, does indeed equal right hand side. We can make that assumption because in a case like this, we're simply told solve the equation. So if the directions read solve the equation, you can make that assumption from the very first step that the left-hand side does indeed equal the right-hand side, which allows me to apply properties. Subtract the 3x from both sides, or additive inverse property. Subtract the 5 from both sides, another additive inverse property. So all these properties, you may not remember the names, but you know what to do. You're moving one to the other side, it switches sign, that kind of idea. And again, we're allowed to do this because we can make the assumption that the right-hand side is indeed equal to the left-hand side. Now, this very first part of Chapter 5, and part of what we will be solving equations in Chapter 5, so it's really important you understand the difference between solving an equation and verifying an identity. Now we're going to look at verifying. When you are told, we don't call it an equation because we cannot assume it's equal. So we call it identity. We are determining if indeed the left-hand side equals the right-hand side. And that is a big question mark. And because we cannot assume they are equal to start with, we cannot apply these properties. We can't just move one term over to the other term. We've got to be very careful to only manipulate the right-hand side and only manipulate the left-hand side, but until we get them equal to each other. So what does that mean? Suppose I had to verify the identity and it looked something like this. Now, because we're verifying, the way you need to think about this is a very strict line, straight down. Sorry, I'm outside and my dogs are going to bark. And what that line is essentially saying is you cannot move anything from either side. What you can do is take a look at the individual sides. So let's take a look at the right-hand side first because that's the simplest. There is nothing I can do to the right-hand side. It is in the most simplest form I can possibly get it. So we're going to leave that alone. Now let's look at the left-hand side. I can manipulate the left-hand side. I can apply distributive property as long as I'm keeping everything to the left of that green line, that equal sign, or the green line that I just drew. So what's that? 3x plus 15 plus 2x minus 14. All right. I applied distributive property. It doesn't involve the other side of the equation, so we're good. Now I can continue to apply different things like bring like terms together. 3x and 2x, well that's a 5x. And 15 minus 14 is 1. Positive 1. So you keep bringing this equal to sign down until you say, hey, yes. You give it a little check mark. You have verified the identity. But you showed the steps to do that. Okay? When you verify an identity, you're only allowed to work on the left-hand side or the right-hand side. You cannot go across the equal sign. When you are told to solve an equation, that's a different story. You can apply properties like the additive or multiplicative inverse properties, meaning I can divide both sides. It's that idea of the scale. You already see here, when you're solving an equation, you already know your scale is equal, so you can move weights around and move things as long as you do. It's that old adage, as long as you do the same thing to both sides of the equation, you keep it equal. The problem when you're verifying identity is you don't know it's equal. So you cannot add things to both sides of the equation. You must work with them separately until you get them to the same thing at the end. Once you get them to the same thing, you can check it off. Now here's the good news. Every time you have to verify identity in this course, in this chapter, you are going to be able to verify them. What you have to show me, though, is every single step. You want to treat these like proofs. I can only give you full credit if you show every single step to get there. Now you might be asking, what are the steps? Well, I'm going to go through a series of examples in the next video so you understand the steps. The steps are justifying. You're going to use the trig identities that you've already learned in this course for the first set to verify identities, and you will have to justify each step. So it's kind of like painstakingly showing every little step, because if you don't show it, you can't get the credit. You know what the answer is at the end. You know the left-hand side is going to be eventually equal to the right-hand side, because I just told you every identity can be verified for this particular. I mean, that's not like that in life or future math courses, but for this course, they can be. You have to show me the steps to get there. Okay, so I'll see you in the next one to start verifying trig identities.